All right, sorry about that. So picking up with this equation, here we're just given the slope and a point, so that's easy to write point slope form from. So it's y minus 4 equals negative 2/3 times x minus negative 1, which is going to be x plus 1. So there's point slope form. If I want to get that into slope intercept form, I will distribute the negative 2/3. So now it's negative 2/3 x minus 2/3 equals y minus 4. I need to solve for y, so I need to add y to this side, add 4, to this side. And then remember, when you're adding a fraction to a number, you need to get a common denominator. So 4 is really going to be 12/3. So y is equal to negative 2/3 x, and then negative 2/3 plus 12/3 is plus 10/3. Here's a case where I wouldn't want to plot 10/3, 3 and 1/3 on the y-axis and then try to do a slope from there. It's much easier to plot the point that was given, negative 1, 4, and then apply the slope. It's negative 2/3, so down 2, right 3. And maybe I'll do a couple of those just to get more accurate since I don't have a straight edge. And so there's my line. Now I should be able to match up that yes, at 1, 2, 3 and a third about is where my y-intercept is. So that's a good way to check. But slope-intercept form is not always the best way to go if you're to start from if you're trying to graph the line. Okay, what else? We need parallel and perpendicular lines, so you need to remember what the rules are for this. So two distinct non-vertical lines are parallel if and only if their slopes are equal. That makes sense. If your slopes are the same, if you're headed in the same direction at the same pace, then you're going to be, or at the same slant, I should say, then you're going to be running alongside each other without actually crossing. Two non-vertical lines are perpendicular if and only if their slopes are both opposite, meaning opposite signs, opposite reciprocals. So for example, if one slope is 3, the other slope is negative 1/3. So write equations for the parallel and perpendicular lines in point slope form for, we're just going to do one problem here. So we want our line to pass through this point, and we want it to be parallel and then another one perpendicular to this line. So the first thing I need to know is what is the slope of this line? So I like to get this into slope intercept form. Subtract 2x, divide by negative 3, just to see what the slope is. So negative 2 divided by negative 3 is positive 2/3. Y-intercept would be negative 5/3. We don't care about that. It's this slope right here that we care about. So if I want to write a parallel line, the slope for the parallel line I'm going to use is the same, 2/3. If I want to write a perpendicular line, the slope for the perpendicular line is going to be the opposite reciprocal, so negative 3 divided by 2. All right, so let's start with the parallel line. So we're using this point and this slope. So y plus 1 minus negative 1 is going to equal 2/3 times x minus 2. This didn't tell me to write both types of equations, point slope and y-intercept, so I'm just going to write point slope and call it a day. And then what about the perpendicular line? So use the same point, y plus 1 is equal to, now it's negative 3 over 2, x minus 2. All right. Now, our AP exam talks about sequences a little bit. It's not incredibly prevalent, but there were a few multiple choice questions I've been told by my students last year that showed up. And so this is actually something that you talked about back in Algebra 1, but it's been a while since you've been in that class. So an arithmetic sequence sounds very official, but it's just a list of numbers, and the list of numbers is increasing or decreasing by the same amount. So a list of numbers whose differences between consecutive terms is constant. So what does that mean? Well, we call that a common difference. It just means you should be able to see a pattern. Like it should be that from A1 to A2, I'm adding 3. And then from A2 to A3, I'm adding 3. Or I could be subtracting 1 each time or whatever. So there's going to be a pattern that we can look at. And you can always just, you don't have to like wrestle over what the pattern is. You just get it by subtracting consecutive terms. It's got to be the next term minus the previous term. So a sub n minus a sub n minus 1. So term 2 minus term 1, or term 3 minus term 2, or term 100 minus term 99, whatever. All right. And then because there's this pattern, the question that they like to ask us on our AP exam is not necessarily just like, what's the common difference? It might be something like, here are the first 3 terms. What's the value of the 100th term? So, okay, well, I don't want to write them all out. So what's a quick way to figure this out? So let's use the common differences to derive a formula to find any term in the sequence, whether it's the 10th term, the 100th term, the millionth term, if they want to get crazy. So let's start here. The second term would be the first term plus whatever the common difference is. So maybe it's plus 3 or minus 2 or whatever. Okay, that's fine. The third term should be the second term plus that common difference again, right? If I want to get to the third term, if the pattern is plus 3, add 3 to the second term. But let's generalize this. Let's use some substitution. The second term is also A1 plus D. So let's say instead of A2, A1 plus D. So I just subbed out A2 with that expression. And then let's clean this up. So the third term should be the first term plus 2 times D. And let's do this for a few terms until we kind of see a formula popping up. So, all right, what would the fourth term be? The fourth term would be the third term plus the common difference. Again, if the common difference, if it's like, oh, you add 5 every time, so you would add 5 to the third term and get the fourth term. But what did we say the third term was? The third term was this little formula here. So let's replace that. It was A1 plus 2D, and then we have plus D again. So now we have that the fourth term is the first term plus combined like terms here, 3 times D. So maybe you're seeing a pattern here. A3 was A1 plus 2D, A4 was A1 plus 3D. We could do A5 if we wanted to. Or do you see the pattern here? What about A sub n? What's the general term? Or what's the general rule, general term, whatever. If I want the nth term, I'm going to start at A sub 1. And then what is this number that's in front of the D every time? When I was looking for the third term, it was 2. When I was looking for the fourth term, it was 3. When I'm looking for the nth term, it's going to be whatever n minus 1 is. So if I want the 100th term, it's going to be 99 times D plus A1. All right, so this is our general formula. This is something that we will be kind of practicing, studying. I'll remind you of this again as we review for the AP test at the end of the year. But it's kind of a nice little formula, so let's check this out. First of all, determine whether or not the sequence is arithmetic. So is there a common difference? So is D constant? Is really what that's asking. So that's another thing they might ask us for our AP exam. If it is arithmetic, let's find the next 3 terms, and then let's determine the value of the 100th term. Sequences, by the way, are something that we look at in BC calculus. So if you are BC bound next year, we'll look at these a little bit further. So we have the first 4 terms right here. Let's just subtract consecutive terms to see if we get a common difference. So 3 minus negative 3 is 6. 9 minus 3 is 6. 15 minus 9 is 6. So yes, it looks like we have a common difference, and D is 6. So I would say that this sequence is arithmetic. Okay, and then it said find the next 3 terms. So what are the next 3 terms going to be? I'm not going to use the formula. I'm just going to add 6. So the next 3 terms from 15 are going to be, so let's see, we've got negative 3, 3, 9, 15. So the next 3 terms here, add 6, 21, add 6, 27, add 6, 33. Okay, so those are the next 3 terms. What's the 100th term? What is A sub 100? It's A1 plus 100 minus 1, 99, times D, which is 6. What was A1? A1 is always the first number. So negative 3 plus, let's do a little multiplication over here. 6 times 9 is 54. 6 times 9 is 54 plus 5 is 59. So apparently that's 594. So the 100th term, negative 3 plus that, is 591. So that saves us from having to keep track and add 6 until we get all the way out to 100, which would just be ridiculous and time consuming. What about this one? Are these terms, do these have a common difference? So you might notice a pattern in this. Looking at this, it's like, oh, I can multiply by 2 every time. But that means that there's not a common difference, right? 4 minus 2 is 2. 8 minus 4 is 4, so that's a problem. 16 minus 8 is 8. So there's no common difference. In other words, D is not constant. So that means that this is not an arithmetic sequence. So disappointing, but the good news is you don't have to find the next 3 terms. You don't have to find the 100th term. That's all that we're going to do with that problem. And so we're going to practice this a little bit more. But remember, you can always, if you study this formula, I will expect you to have it memorized. If you study this formula, you can get to any term that you want, really.